Interesting. हाँ, मजा आएगा आपको. So let's start with. So initially we'll have a lot of discussion. Our chapter is electrochemistry. A lot of these things we have actually studied in the chapters before. Okay. Now this chapter in your textbook always starts with a discussion which is known as the hydrogen economy. Now that is a discussion you also should participate about. Okay. Now if you look in the world today, now we have a huge energy requirement in terms of whether it is like transportation or whether energy requirement. So we say that the watt demand, what is the unit for power, the watt demand for every person, and is going up and up day by day, right? So what are the sources of energy that we have if we look at the transportation sector? So it's all the fossil fuels that you have. Now fossil fuels are what? Non-renewable sources of energy. Okay, in your lifetime you can't renew them. But bigger than renewing them, the problem that is posing up is the pollution that is happening. Over and above, if you know, the temperature of the earth is going on increasing day by day. So what this world is now trying to do, there is something called 2050 as a target, where you know you have to have sustainable practices, otherwise nothing is going to stay. If you see, we are now in October, still sweating, right? Then there are places like cold places where people are buying refrigerators, like where I have been born, brought up, we never saw fan. Now ice creams are also being sold. So the entire global economy, also the global weather and everything is getting fluctuated. So one of these aspect is, can you replace the conventional carbon emission fuel? So if you see today, we have got a lot of electric vehicles that are plying on road. But again, electric vehicles, are they completely solution? Well, how was the battery manufactured? That's still a question. If the battery is manufactured with a process which is consuming energy by burning the same fossil fuel, then you are not being green in your process. Yes, you are green to a certain extent, that when you are driving the vehicle on the road, you are not having emissions coming out of it. But how has the battery been manufactured? The battery has been manufactured. So let's say let's talk about something. Let's say if you see a factory, okay, let's say if you see a factory, then this factory needs power. That is the first thing, you need power, or in other words, you actually need energy. So one of the ways the cheapest way that the energy can come to you is that it comes from, thermal power stations. Thermal power stations means where you're burning coal. Whether if we are countries in India, or we are the country like America or wherever it is, coal is the thing. You burn coal and you're getting power. We are also getting power from coal. Okay. Another way in which you can meet these power requirements is if you have nuclear power. And then the type of power that we have, those powers are such that they are good to have, but still not at that scale in which you can run industries and you can feed the requirement of cities. They can be like power from tidal sources, wind, then geothermal energy. Okay, geothermal energy, as well as in thermal also we have one more called hydel power project. So all hydro based, where water falls and the turbine goes on, like you have Sri Salem nearby. Okay, it's a hydro power project. So hydro, nuclear, thermal. What do you actually do in all these? See, you have to understand, then only you will understand this chapter. In everything you have basically what is known as a steam turbine. You have a steam turbine, and a steam turbine is something which will use steam and it will convert it into mechanical energy. As a result, the turbine will have a shaft which will rotate, and this shaft will be connected to your generator or alternator, as we say. Right in your apartment below, when power goes, you have got a generator, so you have to turn the shaft. How do you turn it? You've got an engine. Same engine that is there in the bus is there in the apartment below. How are you starting the engine? You're using the battery to start it, and then it is running on diesel. So, but you are using carbon fuel. Emissions are happening. So the power that is coming to a house, you are not aware. So the power that comes to a house comes through a steam turbine, or it can come from a gas turbine. Like if you see Krishna Godavari basin in Andhra and all, they are gas turbine. But end of the day, either natural gas is being fired, or steam is being fed. Now, how you are getting this steam? You are getting this steam by heating what we call as water. So water is producing steam, and steam is turning this. So the turbine will have blades like this. Okay, it will have blade like this, and the blade rotates, and the shaft rotates the generator. End of the day, you have to rotate something. Now water is converted into steam. In order for water to convert to steam, you need heat. This heat is coming from coal. In fact, Ramagundam is the place out here from which we are all getting power. Every day, wrecks and wrecks of railway wagons are going with coal. If it doesn't go for one day, you will be without power. So much is the requirement. Are you understanding? So if so much coal is being burned, so much carbon footprint is happening. Now, how do you replace this coal? In nuclear power plant, what we are doing, we are having a nuclear fuel. Nuclear fuel is being used and that heat is used to generate steam. So coal is taken up. So nuclear fuel is very clean fuel. If the nuclear power station is properly controlled, which it is, then nuclear power is very cheap, very, very cheap and very clean fuel. No questions arises. And these are very clean power, like hydropower. In hydro, what happens? Falling water will rotate the turbine. Right? Falling water will rotate the turbine. So, theek hai, chalta hai. Tidal is also good, geothermal good, but the problem is these are not going to feed my requirement. We don't have technology that these can feed. So ultimately, we are dependent on what? Coal. Now, our story shifts and we can come to the sector which is known as the transport sector. Now, the whole story starts with hydrogen being used as a fuel. And this is a big talk nowadays, big talk. Hydrogen as a fuel. And as students of science, you should know about it, participate in debates. People are buying stocks of companies which are into hydrogen. Rather, we say companies or projects which are promoting green hydrogen. So, abhi hamara focus should be on green hydrogen. Isi ke upar sab kuch, the next discussion. Okay. So, what is hydrogen? So, if suppose in Australia and all, there are buses which are hydrogen fuel buses. So, how does a hydrogen fuel work? You know, you have got hydrogen and you react it with oxygen. It forms something called water. Look at how stylish it is. Hydrogen reacts with oxygen to give you water. And this process is exothermic. Do you know what is exothermic? Exothermic means it gives out huge amount of energy. This gives out huge. This energy is very, very high. Right? If I can tap this energy to convert it into electrical energy, my electric vehicle can move. How does the electric vehicle move? An electric vehicle, this Nidhi, they have got electric car. How does it move? It does not have an engine. It has got motors inside it, just like the motor that is there in your fan. And it will be very quietly moving. Who is powering the motor in their car? The battery is powering the motor. How was the battery manufactured? From a factory. How did the factory get the power? From coal. So is the process complete green? No. Right. So we have to now look. If I have a reaction where hydrogen and oxygen combine, it forms water. Look at the output. This output is so stylish that this is something which is neutral. Do you agree? So would you mind if a bus is driving on the road and it is like in front, rather than the exhaust gases giving you exhaust emission, it is just dripping water? Do you mind? You don't mind. Very good. Are you getting energy out of it? Yes. Can this energy be converted to electrical energy? It is being done. It is being done. This is possible. Problem now that is happening in the world is oxygen. The bus has got an engine which sucks oxygen from the atmosphere. God has given you free of cost. ये कहाँ से लाएंगे? ये चाहिए. Now the problem with hydrogen is that the buses which you have, like in Australia, even in Maharashtra, we have some buses which are running on trial, hydrogen fuel buses. The problem is these buses carry cylinders of hydrogen. Cylinders of hydrogen. Where is the hydrogen coming from? Well, to get this hydrogen, right now we have got only one process, and the process that we are using is we have natural gas. What is natural gas? The gas you are getting out from coal and petroleum. Again, fossil fuel. So natural gas, this we will study later when we say in natural gas, we do a process of steaming. So again, the question comes, is the hydrogen clean? No. So this hydrogen is known as, children, gray hydrogen. Gray hydrogen. And another problem, if you take hydrogen in this manner, hydrogen has got low density, highly inflammable. It is almost a bhasmasur, highly combustible, and packaging it becomes problem. So there are now some fuel stations where hydrogen is available as a gas, just like CNG. The bus goes and parks and it starts filling its hydrogen cylinder. Question is, how is the hydrogen kept in that fuel station. They must be keeping it in some storage bullet. How did you manufacture that hydrogen? So the same story like the electric car battery. Now the world is all talking about, there are many companies which have come, which is like green hydrogen. Green hydrogen's concept is, if you can produce the same hydrogen from a nuclear or a hydro or a tidal, then this will be known as a green hydrogen, because you are not having any carbon footprint to produce this hydrogen. The entire chapter will hover on this when we go later in this. Are you understanding? Is hydrogen ko agar aap cleanly produce kar pao. Now what is that clean process? Is this much clear to you? One of the clean processes is this output product, H2O. If you actually do something called electrolysis of this process, electrolysis, paralysis means disconnecting an organ, thermal decomposition, photo decomposition, discomposition due to electricity is known as electrolysis. What do you get? Hydrogen. And what do you get? Oxygen. What are you taking in? Electricity. This is still not cost competitive, and still not in a way, engineering wise we will say possible. Commercially, is it acceptable? Still no. It's like, I am able to make a paratha, price of each paratha is coming 3,500 rupees. Can I sell it in the market? No. So it's not techno commercially viable still now. Now people are even thinking to get hydrogen from bamboo. Bamboo is the tallest growing grass. If you know, bamboo grows the highest in a day. A lot of bamboo plantations and a lot of things are happening. 2050 is the target in this world to change into this concept called green hydrogen. So if you have a hydrogen fuel bus, very good. It does not produce any emissions on the road, which is same like a electric car. The question is, how are you getting the hydrogen? Right now, the hydrogen that we are getting is known as gray hydrogen. And the hydrogen that we would like to have is green hydrogen. So what is green hydrogen? Green hydrogen is hydrogen when it is manufactured using energy which is obtained either from nuclear, tidal, hydro. You should not use, your factory which is producing hydrogen should not use carbon fuel, because otherwise the temperature goes up like anything. If you are using carbon fuel, then it's not about wasting it. So is this introduction part understood? The hydrogen economy. The world is all fighting for a green hydrogen. Green hydrogen means it's same hydrogen produced from a green process. What is green process? In order to manufacture the hydrogen, I did not use energy from a thermal power station or by burning gas-based power station. Means fossil fuels were not put into use. And the best way is the water that you are producing. See, the process becomes so efficient. The product, this is the byproduct. If hydrogen and oxygen combine together, they produce energy which is converted to electricity and the bus is running. The product that you are producing again have a mechanism to break that product. If you break the product, then what do you get? Hydrogen. But this is not coming cost effective as of now, breaking this product. So some of the safety, and hydrogen has got a safety related issue. Right now, the hydrogen, that the way that we are having buses, it is carrying hydrogen as a stored cylinder, which is not safe. Rather, kuch process aisa hona chahiye. I don't need hydrogen at that heavy pressure and all. Hydrogen should keep on coming and I should keep on producing hydrogen. Sometimes don't you think, how is oxygen produced in a submarine? 6-7 months, a submarine, like a nuclear submarine, you know the difference. Do you know the types of submarine? We have got two types of submarine, battery operated and nuclear. The battery operated submarines have to come up once in some days to charge the battery. Nuclear submarine can quietly go down and remain for 6-7 months. कुछ नहीं है, आवाज भी नहीं करेगा वो. 6-7 महीना. How will you breathe? And a submarine is not supposed to have gaseous exchange. Are you understanding? It's supposed to be a quiet vessel. If it does lot of bug hawa chhodega, then to you will be torpedoed by the enemy. That's also very nice reactions are there. How and you will be breathing out carbon dioxide. So it has to be a recyclable process. So this is the story. So that brings us to the introduction of this chapter. Like what we're going to study about electrochemistry. We're going to study a lot about electrolysis, So now we get into a chapter. So hydrogen economy, because many places we don't teach the introduction part, but here this is important because for the days to come, this is a technology which if you are not able to answer in a group discussion or something, so it says, write the overall, what is the word equation for overall reaction in a hydrogen oxygen fuel cell? So in a hydrogen oxygen fuel cell, what happens? We'll study this. Hydrogen combines with oxygen to produce water and gives you a lot of energy. This is the fuel cell equation. And how do you get the hydrogen? If somebody says how to get the hydrogen, well, one way will be to again to do electrolysis of the water. But right now in buses, that is not being done. Buses carry hydrogen. Once hydrogen is over, the bus has to stop, refuel hydrogen. Do they fill oxygen? What idiot. Oxygen they're going on sucking from the atmosphere as and when required. So process is very thing. Okay. Now, use of hydrogen fuel is regarded as non-polluting for the environment, but what factors must be considered for it to be regarded as carbon neutral? So it is non-polluting. Same as Nidhi's car, non-polluting. But if you want the car to be carbon neutral, how was the battery manufactured? And from where did you source the hydrogen? If you have sourced the hydrogen from a gray source means where you have burned carbon fuel, then we are not carbon neutral completely in the chain. Okay, आगे बढ़े. So now we go back to our chapter, and our chapter starts with what was known as electrical conductivity. Same concepts, nothing great that you will understand. Electrical conductivity. And if you have any doubt, do ask me. So first we will take up electrical conductivity in solids. Okay, let's have a discussion of electrical conductivity in solids. Okay. Now, if I see solids, the solids can either conduct electricity or does not conduct. It can be two categories only. They can conduct or does not conduct. If you conduct, then you can be a good conductor. I'm not using the word excellent. And you can be a bad conductor. Please understand, a bad conductor also conducts, not as good as a good conductor. And if you do not conduct at all, then what do I call you? Insulator. So insulators are the solids which do not conduct electricity at all. And if a solid conducts electricity, then that solid will be known as a conductor. And the conductor can be good conductor or bad conductor. Let's say, for example, silver is considered to be the best conductor. Okay, if you want to ask for example, then silver is considered to be the best. That's why all our phones and motherboards of PCs and all are with silver soldered. Then you can ask, sir, why is silver not used in our household wiring? Now we have a lot of thieves and pilferages happening. तब लोग wire काट के बेच देगा बाजार में. ठीक है? So silver, copper. But if I say between copper and iron, who is a better conductor? Copper is a better conductor. So there can always be preferential grading. Now, if you look into the molecular structure wise, then you will see that the solids which are metals, only those metals conduct electricity. Now we are going a little bit deeper. See, solids which are metals, they conduct electricity. Okay, out here I will put my exception also. I have an exception here. Can you tell me what is the exception? What happened? Carbon. Carbon, when it is in the form of graphite. Kya ho gaya? Chemical bonding, we have learned all these things. Carbon, when in the form of graphite, also conducts electricity. Now that's an exception. Okay. So if you are a solid and if you are conducting electricity, you are a metal. Okay. There is another metal which is in liquid form, mercury. That also conducts electricity. Okay. Now, when we are talking about metal, we also have to give the place to, although I'm discussing solid, but I will give some place to mercury also. And mercury is usually liquid. Why I'm classifying them all in one part? Now children try to see the beauty of it. Now, if I group these metals, the graphite and the mercury, something is common in them. That is the presence of something called free electrons. You remember free electrons? Metallic bonding. In metallic bonding, there will be free electrons. Very good. Look, that is known as, also we call them as delocalized electrons. Delocalized electrons, also known as sea of electrons, also known as cloud of electrons. Now these cloud of electrons are the ones who have been contributed by every atom but now have forgotten their parents. They don't know who their parents are, and they are scattered all over the bonding, just like you put ointment on your body. And if you see any external stimulus means if I give any external voltage to it from a cell or something, they immediately start getting aligned and start moving. Movement of anything is known as current. Water moves, you say don't go, there is current in the river. Wind has got current, so movement of charges will be known as, see, for current to constitute we should have movement of charges. Ye bhi very, very common, right? What is electric current? If you see electric current, then electric current is movement of charges, right? And we are now talking in solids. So if you talk in solids, then these charges are nothing but electron. Is an electron a charged particle? Yes, it's a charged particle. It's a negatively charged particle, and these negatively charged particles are the ones who are responsible for conduction of electricity in solids. And when we talk about solids, let's dive one level more deeper. These solids are metals. There's somebody called carbon, only when it is in the form of graphite. And there is one more metal who is mercury, but in that it's normal temperature, it will be in liquid form. All these three things are conducting electricity, means they should have some common property. The common property is the existence of free electrons or delocalized electrons or sea of electrons, right? So the question comes that then we can say, if we are talking more in terms of these metals, children, then these metals are the ones which have what? Metallic bonding. ये पढ़ चुके हैं हम chemical bonding के class में, right? And if you talk about these people, then these are the ones who are the covalent bond, right? Non-metal, covalent bond solids, okay? Covalent bond solids, and which are non-metals. Hey, don't get confused, huh? Non-metals does not mean liquid. Non-metal can be a solid also. Non-metal can be a solid. Phosphorus, sulfur, wax, non-metal solids, but they are covalent bond. And whether in this covalent bond, you can be two types: giant molecular structure, giant molecular, somebody like diamond, you remember, or you can be a simple molecule, something like say sulfur or iodine, whatever it is. Let's say you are sulfur. In either cases, my dear, y'all are not going to conduct. Why y'all don't conduct? Because y'all are covalently bonded. A covalent bond non-metal, let's look at iodine, I2 होके रहेगा, like sulfur S8 होके रहेगा, or a giant molecular structure does not have free electrons. So the story comes out, if short questions may come, they have no free electrons. Have you understood this or not? Let's make our story very clear. We are talking about solids. We are talking about conductivity in solids. If solids conduct, then they are known as conductors. If they do not conduct, they are known as insulators. If they conduct, then they can be preferentially good conductors. So excellent conductor, good conductor, bad conductor, but all of them should have free electrons. And if they do not conduct, then they are insulators. So what is special in conductors and insulators? Conductors usually will be metals, or a metal in a molten state, or as an exception has a non-metal called carbon when it is in the form of graphite. Diamond is also a form of carbon, but diamond is giant molecular structure, covalent, does not conduct, but this one conducts. ठीक है, clear है? तो यहाँ पे हमने क्या देखा? So what we are trying to study here is that the presence of free electrons. Now let's see this presence of free electrons. Is this structure clear? Any bachcha has any confusion or anything to ask out here? As of now, we're only talking about solids. Fine. लिखना है, लिख सकते हैं. So if you write, after understanding, you can say, sir, pause for 2 minutes. You also take rest. We also write. Then what happens? You get your picture clear. And don't try to copy everything the way I am writing. You make your mind map on your own way. If you have listened to what I have been blabbering for last 5 minutes, and if you have listened to it and you have understood it, you can make your own way. So all you need to show is that I have got a solid. A solid, if it conducts, is a conductor. If it doesn't conduct, it's an insulator. If I'm a conductor, I can be a metal. I can be a metal in the solid state, or I can be a metal in the liquid state like mercury, or I can be a non-metal carbon in the form of graphite. In all these three scenarios, I have something common, which is the presence of free electrons. End of the day, for current to flow, charged particle has to move. An electron is a charged particle. Now we will see how that electron flows. Can I rub this now? If all is fine, okay. Fast तो नहीं हो रहा है ना बच्चा, समझ में आ रहा है तो right, very good. हाँ, बाद में जाके गाली देना मेरे को, वो अलग बात है. So let's see the structure. Okay, let's see the structure. So let me bring out a solid. So let's say this is a solid, right? And what I do is that I connect this solid, something like, see, this and this and now see the interesting thing. आपको picture clear हो जाएगा. Now what we are saying, there are a lot of free electrons out here. There are free electrons out here. Now these free electrons are scattered outside, just like आवारा बच्चे की तरह है. You have to make the electrons move out here. So all you need is, you have to either have some sort of a carrot you have to show, come, it has to come, or you have to kick the electrons. In other language, we say if water has to move in the pipe, you need to have a pump. The pump is going to pump the water and the water is going to gain energy. When does something move? Something moves when it has momentum. Recall your physics. Momentum means you have to have energy. Now, who is going to give the energy? The energy is provided by the battery. Do you understand? So my battery is now providing the energy. And now just have a look. Now, I say that this is the negative terminal of the battery. The larger one is always the positive terminal. And the battery, we always say this is higher potential, this is lower potential. Okay, higher potential is this side, lower potential is this side. Now, if you are negative, then what happens on this side? This side becomes negative, yes or no? So all the electrons which were present here, the free electrons, these free, you have a free electron here, you have a free electron here, you have a free electron here, free electron, free electron. As soon as this sort of a scenario happens, don't you think these free electrons will start repelling from this one? They'll repel? Negative and negative, इतना सोचने का क्या है? इधर में negative potential देके रखे हो. Like charges repel. And the way once they are repelling, then let's see what is happening on this side. This side is positive now because you're connected to the positive side. So the electrons are being now attracted. Very lucrative scenario. Repel from there and attract from here. And they come and get attracted out here. Like, so my electron is now going to move out from here, 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 here. And again the electron moves. So many children think that battery produces electrons. No, battery does not produce an electron. A battery works as a electron pump. This is the job of the battery. And how does it work as an electron pump? It maintains a potential difference, which we call as PD. That is the voltage. When you say a battery is 1.5 volt, means what? This side is 1.5, this side is 0. It always maintains a potential difference. Just imagine, if a child has to slide down a ladder, you have to have higher potential energy on this side and lower on this side, then only child comes. Agar ladder ko seedha kar doge, will the child go? No. So always the potential difference is required. Then only rich and poor, in economics we say, then only money. If everybody is at the same stages, then there will be no money. Supply and demand, potential difference. Unless you create potential difference, then there will be no flow. So this is the flow which is happening for electrons. Now comes to it. What is current? Current is the flow of charged particles across the cross section of a conductor in an interval of time t. So let's say that if there is a cross section, say this is a cross section. So in this cross section, the current is moving. In later classes, you will study that electric current is given by the rate of flow of charge. How much charge is flowing per unit time? Not to bother your head right now. So in this cross section is going, right? Now, there is another story out here. Somebody might ask, but what is the direction of electric current? Okay, we'll study this here itself. We'll clear it here itself. There is something very interesting. Electrons are moving from where, beta? Electrons move from negative to positive. Whereas the conventional direction of electric current is taken as what? Hey, you robotics man, how does electric current move? From positive to negative. Electric current is taken as this. Now, ye bhi hum seekhenge why it is like this. The green one is electric current. Okay. So, and this story is interesting. So, the yellow one is known as my electron current, and the green one is the conventional direction of electric current. So get this concept today forever in your life, right? Electric current was discovered long back in 17th century, 16th century, 17th century, like your Alexander Fleming ने जब किया था. So when they conceptualized everything, so two type of charges were conceptualized, plus and minus. Nobody has seen a plus charge, nobody has seen a negative charge. All they have seen that these two charges have opposite polarity. So what did we name them as? Plus and minus. We want the traffic to stop. So we thought that red light is the best way to understand, to make the people understand that traffic, please stop at red. And from birth you are understanding that. So it's a convention. उसको कोई अगर green भी लगाता तो कोई problem नहीं होता. It says you have to give something and we have to show some light for you move opposite. So we gave green. So we conceptualize as plus and minus charge. Now which we are in which time period? 17th century. At that time, the direction of electric current was all taken to be from positive to negative, positive to negative, positive to negative, and every book and all theses were written from positive to negative. Now comes 1897, where J.J. Thomson discovers something called electron, and electrons are negatively charged particles, and the truth is exactly opposite of what you have been doing. The truth is that the electrons all move in this way. So now you have got two steps with you. Either you change your all books and thesis and go back to the electron way, or you say that this is the electron movement, but we will always go by the conventional direction. So every electrical circuit, everything that is planned in the world today are as per the green arrows. And in fact, we never study the blue arrows even in electrical engineering also. Nobody will study this ever after. So it's like, when a child is born in Hindu mythology, what do? We give the pen on the right hand. But maybe the child lefty भी निकल सकता है ना. Lefty होने से idiot थोड़ी होगा. You look at Sachin Tendulkar, bats with right hand. You know the story of Tendulkar. Tendulkar bats with the right hand. If you give him to eat something called roti, he eats with right hand. But if you give him spoon and poha, he uses left hand. So that's all convention. So have you understood? Electric current's conventional direction is always from positive to negative. When you study electricity chapter, we will always show current from positive to negative. However, the current is constituted by the charged particle called electrons, and electrons move always negative to positive. That is known as the electron current, and this is known as the conventional. So later on, sir, when we go for any circuit design, any object, any manual or anything, how will we consider current? By this green one. You will never go by the yellow one, and yellow one gets killed here forever. It doesn't make any sense now. I'm saying from tomorrow onwards, if you wake up and I say that the new traffic rule in Telangana is that red is for move and green is for stop, and everybody on the road on that day from start are the new drivers. Do you expect any accident? No. No. So listen to me, I'll clear it. Do you expect any accident? No. Accidents will happen if some previous drivers come to the road, because they'll now get confused. Say suppose everyone died and a new generation has come up. What is the way to move on road? On red, drive. On green, stop. Do you expect any accident? No. So how does the direction cause you anything? Whether it is this or that? It's current. So how does it matter to me? It's a current flow. Now, ulta dekhe to ulta dekh ke karte na. Sun rises in the east, you think. Actually, son, you are in this part, so you are seeing sun rises in the east. On which side is Singapore for you? East or west? East. On which side is Singapore for Australia? West. Does that mean Singapore has changed? It doesn't change. We say Far East. Far East means countries like Cambodia, Philippines, Singapore, and so called up till say Japan or say Hong Kong. When somebody in Australia says Far East, then what is his East? More towards the Pacific side of Australia, America. That is their East. It doesn't make any sense. Direction is direction, end of the day. Okay. So this is how, so if somebody asks you what does the battery do, the battery is always working as an electron pump, maintaining a potential difference. The day this battery ceases and there is no potential difference, the electrons also stop. They don't move because these negative and positive polarity ceases. Why should the electron move? The electron moves because it is getting a kick from here and an attraction from here. Understood? Now the story is that when we talk about conductivity in solids, okay, we're discussing conductivity in solids. Some of the things that you have to see, that let's say the wires in our house, as I used to say, 20 years, 12 years have gone, have the wires changed? No, they don't change. So in solids, if you actually pass electricity, then there is no chemical change. I hope you understand what is chemical change and physical change. Chemical change means new substance. No, chemical change always means is a clear rakho. New substance, new properties. New substance and new properties. So a chemical change involves something which is known as a chemical reaction. And new substance, new properties will always happen with slight exchange. There will be exchange of energy. And this energy will be either in the form of sound, light, or heat. That's when a reaction takes place. Oxygen is a supporter of combustion. Hydrogen is combustible. They react together to form a new substance called water, whose property is a fire extinguisher. Both the parents were fire supportive. The child is a fire extinguisher. Just see. Are you understanding? Oxygen and hydrogen both have affinity to fire. Water is used as a fire extinguisher. So new substance, new properties. So a chemical change. So when you pass electricity through solids, you do not see any chemical change. That means that solid, the substance remains unaffected. And but I'm not talking something rocket science. You look at the wires in your house. 10 years have you are in Platinum Tower from your childhood. Have you changed wires? No, the wires remain as wires. So when we talk about conductivity in solids, we do not expect any chemical reaction to take place. And if you talk about electricity, as I said once in previous class also, if you talk about electricity, see, all are interconnected. Electric current has three effects. One is known as the heating effect. One is known as the magnetic effect. Now these two are studied under physics, and the third one is known as chemical effect. And this is a totally different branch studied under chemistry. And what you are learning in this chapter is chemical effect of current. That's electrochemistry. And you started with solids. Solids, there is no chemical effect. So solids will not be our discussion in this chapter. Does it make sense now? Solids. And when we are talking about solids, please understand we are including one molten metal also, mercury. That don't consider that as a liquid. It's a liquid, but don't consider that as a liquid means, okay, hold my discussion. I'll come to it when I talk about this. So when we are talking about solids, it's all about metals. It's a metal in a liquid form, which is mercury. And you can also talk about alloys, solids and their alloys. Their alloys also have these alloys like constant and manganese and nichrome and all. They also have these free electrons. Okay, so alloys behave exactly like solids, and you don't expect any chemical change to take place. That's where, wait, I'll just see whether we have missed out anything. So electrical conductor, yes, we have discussed about this, and that's fine, nothing that we have left. Time now to talk about conductivity in liquids. Any questions so far? All okay? Chalo. Let's now go to conductivity in liquids. Conductivity in liquids. Okay. Now, again, a liquid may conduct or it may not conduct. When you're talking about liquids out here, please understand we are not talking about molten metals out here. Okay, these are different liquids. Liquids as a compound, liquid as a compound. We are not talking about liquid like mercury and all. That is discussed in solids itself, right? They can conduct. If they conduct, we call them as electrolyte. And if they don't conduct, we call them as non-electrolyte. Now, these electrolytes can be again, no, we don't say good and bad here. We say strong electrolytes, or we can call them as weak electrolyte. Have you understood? Right. Strong electrolyte or weak electrolytes. Now, how to check whether an electrolyte conducts electricity or not? Well, a very simple setup we can do. Our setup will be something like this. We usually take a glass tank. This is a glass tank. Glass because glass does not react with anything. And then in this glass tank, you can put your liquid. क्या हो गया? पानी पी ले, अच्छा से खांस लेने को. You have your liquid which you want to check whether it conducts or not. Okay, this is the liquid whom we want to check whether it's your fine. Look upwards a little bit towards the ceiling, it will automatically settle down. Okay, so we have got our liquid, and this liquid is inside a glass tank. So this glass tank is known as a electrolytic or lytic tank. Usually this is made up of glass so that you can see through it and it does not react, right? And then what we do, we will be dipping 2 electrodes in it. Electrodes are the solid bars which will be actually dipped in, and their job will be to take the current inside the liquid. Okay, so we have 2 bars. So what material we can use? These can be graphite electrodes also. Graphite does not react. So carbon electrodes, we call them as carbon electrodes. Carbon electrodes. So what is an electrode? An electrode is a solid which is dipped into the liquid. Rather, later we'll call dipped into the electrolyte. Its main job is to guide the current into the liquid. Right now, I'm not calling it as electrolyte because I don't know whether it conducts or not. So I'm just going to check how to test whether a liquid conducts or not. Okay, and then we go back to our normal setup. So what's our normal setup? Our normal setup will be, say, suppose a battery or a power source. Fine, very good. Put it here, and then what we do is we bring it here and we connect it here. We connect it here. Okay, that's not the right way to draw, by the way. So, and this is my electric bulb. So very simple. If the bulb glows, that means what is happening? That means current. Now I'm drawing electric current. It's not electrons because we have forgotten electrons forever. We'll never discuss. So the current is moving from here to here, and then the current is moving. Now there's something interesting discussion. This is a connecting wire. This is a connecting wire. So the children don't get confused. If sometimes they give you, with mapping, this is a conductor because it's a connecting wire. It's a conductor, solid. You don't expect any chemical reaction to take place in this white part because it's a conductor. And if this bulb gets lit up, that means the circuit has been completed and this liquid is conducting electricity. How it is conducting, we'll see later. If this gets lit up, then I call this liquid as what? What will I call this liquid as? Electrolyte. And if it doesn't get lit up, I'll call it as a non-electrolyte, right? Now, if I pour in some other liquid out here and suppose the bulb glows much more brighter, then the other one is a better electrolyte. It is conducting better. That's why the bulb is going brighter. So I call it a stronger electrolyte. Are you understanding? Right? I'll call it a stronger electrolyte. Now the question comes sometimes is that if the bulb does not glow, it is not a confirmatory test that it is not conducting. Maybe it is conducting and the current is very feeble in the circuit. The current in the circuit is very less, which is so less that it is unable to glow this bulb. In that case, we should have an option to check it separately also. So one of the way will be replace the bulb with something called an LED. Because an LED needs very less voltage, around 3 volts. Usme wo jal jayega. Or many people, what they do, they will take a magnetic compass and they will take a wire and they will wound it around the magnetic compass and then take the wire. This is another thing, just understand it. Any current carrying wire, no matter how small the current may be, behaves as a magnet. So if there is a current flow in this wire, then what do you expect? You will expect the magnetic compass, which was initially say at a position, say something like this, it will just deflect. Is this funda understood by you? Any current carrying wire behaves like a magnet. Take a magnetic compass. Yeah, I'll explain it. Take any wire, any current going wire. You take a magnetic compass and you go near the wire, you will see always the magnetic compass deflecting. Because a current carrying wire behaves like a magnet. There is a magnetic field around every wire. So if you take a magnetic compass, it will deflect. We actually introduced a bulb. A bulb will glow when the current is high, but there may be some electrolytes which are weak electrolytes. You just can't say that they are non-electrolytes because the bulb is not glowing. So how do you test them? You can replace the bulb with an LED. I hope you know what is an LED. Okay, you can replace it with an LED. The LED is known as a light emitting diode. It needs very less current to glow. So no matter if the current is very less, the LED will glow, right? Suppose you don't have an LED, what is the other way to check? Take a magnetic compass and instead of the wire going like this, wind the wire around the compass. So if any current is going through this wire, that means a new magnetic field has been created. The compass senses it immediately and starts deflecting. तो आप इसमें डुबो के देखो, जैसे डुबो तो कंपास डिफ्लेक्ट कर जाता है, निकालने से कंपास पे स्ट्रेट हो जाता है. That means current is flowing. Have you understood? If you have a magnetic compass at home, take your mobile charger, connect it to your mobile, don't switch on the charger. Bring the compass near the wire which is actually the charger wire which is connected to your mobile. Let the compass stabilize, begin absolutely near, and then switch on the board. Engage the switch. You'll immediately see the compass is deflected. Because the compass senses that the current is now, because your mobile has started to draw current. And once the charging is complete, the mobile will no more draw current. See, Ashmita is now not hearing. Now she is busy writing. यही प्रॉब्लम है साइंस का. अगर आप साइंस पढ़ते हैं तो साइंस को सुनिए. मैं एक बहुत अच्छा चीज बोल रहा हूँ, ये आप घर में कर सकते हैं. टेक अ कॉम्पास, पुट इट नियर योर मोबाइल चार्जर ऑन द वायर. Don't switch it on. Let the compass stabilize. How will the compass stabilize? It will point towards the geographic north. Yes or no? That's how a compass stabilizes. Then switch on the circuit. Means switch on the charging. Immediately the compass will deflect. And it will be in that deflected position. The moment your mobile is 100% full, it will no more draw current. Compass will come back to its original position. ये छोटी छोटी चीज है. As students of science, if you love science, few things you should have at your house. One prism, one compass, one concave lens, one convex lens. बहुत सारी चीजें आप कर सकते हैं इससे. You can even make light LED bulbs through potatoes or from lemon also you can do. वही सीखेंगे. ये समझ में आया? So an electrolyte can be confirmed by this particular circuit, and the electrolyte can be a strong or a weak electrolyte. Now the question comes, what is the difference? Now let's talk about some electrolytes. Okay, let's talk about some electrolytes. So if you're getting another 5 minutes and then I'll leave you, don't worry. I know it's a theory class. So electrolytes can be acids, can be bases, can be salts, but there is a catch out here. If the salt is in solid, it will not conduct. Take salt. Your mother is cooking at home. She must have one dabba of salt. So instead of all this setup, you take the dabba and you put the electrodes into that dabba of salt. The bulb will never glow. But if this salt is in aqueous state, you know what is aqueous? Water में salt डाल दिया ना, साथ साथ glow करना शुरू हो जाएगा. So, or if this salt is in molten state, either it should be in aqueous or it should be in molten state. So many people think, so if you have NaCl, NaCl is going to conduct only when it is in aqueous or in molten state. Similarly, if you have an acid, let's say HCl, and you have it 100% concentrated, which is never possible, you don't get it in the market, 100% concentrated nahi hota hai, it will not conduct. It will not conduct. Acids must be in aqueous, पानी में होना चाहिए, ठीक है, वो भी हम देखेंगे. So it should be also aqueous, and the base should also be aqueous, 100%. In fact,
so molten state.
Molten state means पिघला हुआ state.
Oh, just melted.
Melted. Salt, and you melt the salt. Have you seen that thing called Stranger Things episode? देखा है? Have you seen the web series Stranger Things? So there they will make brine. You know what is brine? They'll go on pouring sacks and sacks of salt into that sand pit, and they'll see whether the density has gone up or not by putting an egg. Only then when they put the girl inside, she can float and go inside. No? So that is aqueous solution, highly concentrated. Molten means namak ko pigla do pura. 100% acid, if I sprinkle on your face concentrated, nothing should happen. Okay, there's also a myth out it. See, an acid, to show its acid nature, what is an acid nature? When it releases H+, it has to have an aqueous medium. Then you will say, oh sir, how can you say that if you put acid on my face, won't it burn? It burns because you have moisture in your skin. There's water content in our skin, and that is creating the aqueous state. Otherwise, concentrated acid cannot show acidic property because it cannot lose its H+. And if you cannot lose H+, you are not an acid. Who is an acid? HCl. If you lose the H+, then only you are acid. H+ means what? Science padhna hai to aise padho. H+. H+ means an hydrogen atom which has lost its electron. How many atoms, how many electrons does an hydrogen have? 1. And what does it have? 1 proton, no neutron. So you have lost your electron. What are you now? Just proton. That's why acid's process is known as protonation. Chemistry mein bolega protonation. When protonation occurs, acidic nature will be seen. So in a concentrated acid, protonation cannot happen. Understood? So how good is your absorption capacity? I see there is nothing. We are very good ahead in our course. Can we study 5 more minutes if it is fine? If not, we can stop. But children, I don't want you to study because they are theory subjects. Kabhi kabhi bore bhi ho jate ho. Okay. Now, all we have decided that this electrolyte must be in aqueous state. Okay. Now, out here, up till here, what are the charged particles, beta? The charged particles are electrons because it's a conductor. Inside this, it is no more electrons. It is something called ions. Solids, or rather I'll not say solids, conductors have one type of courier service which is electrons only. Electrolytes, don't say liquids. Electrolytes have 2 types of courier services because ions can be positively charged as well as they can be negatively charged. Do you understand? You have a positive ion, you have a negative ion. We'll see the names and everything. So let's just, can I wipe off this board this much? Okay. So let's say if I have something called say NaCl in aqueous mode. Okay, this is a salt. So it is going to split up into Na plus aqueous and Cl minus aqueous. What is electric current? The flow of charged particles. Is it a charged particles? Yes. Is it a charged particle? Yes. Together they are known as ions. This is a positive charged particle, so I write it like this so that I never forget that it is a cation. A cation is a positive ion. So this is known as a anion. So children, whenever you are talking about an electrolyte, whenever we are talking about an electrolyte does conduct electricity or allows electricity to pass through it, and the charge carriers are known as ions, and these ions are of 2 types. You can be positive, you can be negative. If you are positive, please write it like this so that you don't forget, and if you are negative, you are known as an anion. Whereas if you are a conductor, you only have electrons. Is this clear? In this process, there is no chemical change. In this process, there will be a superb chemical reaction. Means there will be 100% a chemical change. Is that clear? So we said that in the conductors, the type of bonding that we saw was metallic bonding, or a stature of bonding which allows free electrons existence, like in the case of graphite, hexagonal stack layers having one electron freely moving per atom. Each carbon is linked to 3 carbon atoms. Carbon has a valency of 4, but in graphite, carbon is linked to only 3. Where is the fourth one gone? The fourth one is ideally roaming all about. That doesn't happen in giant molecular structure or simple molecular structure. Whereas in electrolytes, we will see these electrolytes will be the ones which are ionic bond. Achha, you know, I told you salt does not conduct electricity. Just look at salt, how it is. Sodium ion is linked with chloride ion. Chloride is again linked with sodium. Sodium is again linked with chloride. Are you understanding? What did we call this? We used to call this a ionic lattice. But what is the better name? Formula units. Formula units. It's a lattice. It's a lattice and it's a formula unit. So when you are solid, you are not able to move. Unless a charged particle moves, current cannot be constituted. Current is the flow, is the movement. मत जाओ, पानी में current है, पानी बह रहा है. I am unable to fly the kite on Sankranti. There is no current, wind current. So here, if you are in a solid, as a salt, if you are solid, you cannot move. If you cannot move, you cannot have ions which will be carrying the current or forming the electric current. But once it is made aqueous, they break apart by this reaction and you get ions produced in it. Same thing, if I take an acid, let's say HCl is an acid, right? HCl overall is not ionic. Huh? HCl is a covalent bond. Hydrogen cannot form ionic. How can you form ionic? Ionic is in where somebody donates something. Hydrogen donate कर देगा तो ससुरा मर नहीं जाएगा, उसके पास एक ही तो इलेक्ट्रॉन है. HCl is a covalent compound. But when it is aqueous, it will split up into H plus and Cl minus. Let's take a base, NaOH, sodium hydroxide, aqueous. It will split up into sodium plus and hydroxide ions. So you start conducting. In these, we will see chemical reactions taking place. Understood? So we saw another process where water, water we had passed electricity. So if you pass electricity in water, that process is known as you are breaking water. Breaking means decomposition. What is a decomposition reaction? Any reaction which is of AB format where you can break it into A and A plus B by supplying energy. This is called a decomposition reaction. If the energy is coming from heat, thermal decomposition. If it is coming from sunlight, photodecomposition. If it is coming from electricity, electrolysis. Now comes, is water an electrolyte? No. Water does not conduct electricity. Kya bolte ho, sir? We are always saying don't touch switches with wet hands because the water in your house has got 100% TDS in it. It is not water. What you are drinking is some mixed salt solution. Yeah. So it conducts. Mineral water will conduct more nice. Pure water, if I give you to drink, you'll say there is no taste in this water. In fact, in these ROs and all, there is one cartridge called the silver cartridge, which is the most costly one. That adds all those minerals. Otherwise, that gives us the taste of the water. You must have tasted water in villages and all. If you go, tubewell ka pani piya hai kabhi? तो अलग-अलग type होता है ना. The thing comes because of different levels of salt. Distilled water, which is there inside this battery, distilled water does not conduct electricity. Water cannot conduct electricity. If it is pure, it will not conduct electricity. It conduct. Yes, that's why now question comes. Then, sir, how do you say that in hydrofuel buses you will be electrolyzing water? Question comes that we want to use the water and we want to do electrolysis. Sir, water तो electricity conduct ही नहीं करता है. इसको आप electrolysis कैसे करोगे? You acidify that water. नहीं तो electricity conduct नहीं करेगा ना. Acid add कर. Right. So we'll stop here today. What I want you is to just have a rough read. Products of electricity. Okay, you can just come down till the first question part. We did not discuss one thing, which is this particular electrolytic cells. I could not discuss that. We could not get time to do this. So up to the portion before electrolytic cells, you can just read and come. Okay? Righto? Good. Shastra has seen the clock at least 7 times. As the